class 10 students, a very warm welcome. I'm your Aditi ma'am and today I have brought you the most important numericals from the chapter Human Eye. This is a small chapter, we know that, and we might overlook it, but this is a very important chapter. Lots of tricky numericals can come from this chapter. So in this video, we are going to see all those important kinds of numericals that can come into your examinations. These include most repeated, PYQs, all the PYQs, some conceptuals as well. Okay, so let's start with the very first question. Watch the video till the end because this is going to be very important. Also, let me know if you have any doubt in any particular topic. I will cover that as well. Okay, let's start with the very first topic, with the very first question, and that is, let's read it carefully. Okay, the focal length of a lens is 10 centimeter. So what is given? A focal length of some lens is given. So we'll just simply write focal length of the lens is 10 centimeter. As we read, we write our one funda. Right? Write the nature of the lens. What is the nature of the lens? We have to find the nature of the lens and find its power. We also have to find its power. Okay, if an object is placed at a distance of 20 centimeter from the optical center of this lens, let's just solve the first part of this. Okay, the first part we have to tell what is the nature of this lens. See how you will go about this. The first thing we have to do is, ma'am, the focal length of lens is 10 centimeter. That means it is positive, right? Now if it is positive, that means which lens has positive focal length? Concave lens or convex lens? Ma'am, concave mirror and concave lens both has negative focal length. So positive, that means our lens is convex lens. The first part is solved, right? Now power, for power you first convert focal length into meters. So this will be 0.1 meter, right? Now the power will be what? 1 by focal length. That means 1 by 0.1, correct? That will be 10 diopter. So first part of this whole numerical is solved. Very easy. Did we face any problem? No ma'am, it was easy, right? So next, let's see the next part. What is the next part? If an object is placed at a distance of 20 centimeter, now they are given us the distance of object, that is u. Ma'am, u is always negative, right? So let's just add a negative sign first. Now it is 20 centimeter, let's write that from the optical center of the lens. According to the new Cartesian sign convention, what will be the sign of magnification? We have to calculate the magnification in this case. Basically it's a sign, but of course we will calculate magnification, right? What is the magnification in this case? Let's solve it. U is given. See, F is also given. F is 10 centimeter. Right? Now can I use lens formula and directly calculate my V? Correct? The image distance I can directly calculate it, right? So 1 by F equals to 1 by V minus 1 by U. Now 1 by V I have to find, minus 1 by U will be minus 20. Be very careful while writing the signs. This will be the formula, right? Now if I take this here, this will be 1 by 10. This is positive. If it comes here, it will become negative. 1 by 20 equals to 1 by V. If I take the LCM, this will be 20. So 2 minus 1 equals to 1 by V. So V will be, my friend, V will be 1 by 20 equals to 1 by V. So V is 20 centimeter. Done. Till here, any doubt? Right? Okay, then we have to calculate the magnification. Now this is a lens. For lens, the formula of magnification is simply V by U. V came out to be what? 20. Now U was also 20, but U was minus 20. Right? So U is minus 20. So this cancels out. Magnification comes out to be minus 1. Magnification comes out to be minus 1. And the sign of magnification now is negative. Right? Understood? Very easy. Correct? Okay, let's move on to the next question. The near point of the eye of a person is 50 centimeter. See, whenever we have questions like near point of a eye, okay, whenever we have questions like near point, so what you have to do, they'll give you a near point, let's say 25 centimeter, right? So for corrective lens, see, this is very important. If you just learn this, you will not do any of the question wrong. Okay, for corrective lens, this will be the image distance. This will be the image distance and it will be always negative. Right? Same for far point. For far point, if in question they have given that far point of the eye has shifted to 1 meter, let's say. Okay, far point is shifted to 1 meter. So for corrective lens, the V will be 1 meter now, but negative. In all the cases of far point, of near point, the sign of V will be negative, right? This slide is very, very important. Okay, moving on. Now read the question carefully. The near point of the eye of a person is 50 centimeter. So V will be minus 50 centimeter. Okay, find the nature and power of the corrective lens, right? Of the corrective lens required by the person to enable him to see clearly the objects placed at 25 centimeter. Now this 25, now clearly they have told us that object is at 25 centimeter. So U will be minus 25 centimeter. Right? We just have to find the power. Now to find the power, we have to find focal length. Okay? So we'll just directly calculate focal length using lens formula. Very easy. You don't feel any hurdle. If you feel any hurdle, let me know in the comment section. I'll try to solve it in the live session or the next video. Okay? 1 by f. Now 1 by f equals to, see, minus 1 by 50 plus 1 by 25. If you just take the LCM as 50, it will be minus 1 plus 2, right? So 1 by f equals to 1 by 50. So f will be 50 centimeters. Done? Any problem? Now f is positive. We just saw in the last example, f is positive for the lens which is convex. F is positive for the lens which is convex, right? Convex lens. Also, you can see this defect is what? The near point of the eye is shifted. That means the person cannot see nearby objects clearly. So that is hypermetropia. And to correct hypermetropia, we use convex lens. We found convex lens. Okay, done. Now to find the power, we have to convert focal length into meters first. So this is 50 centimeter. 50 centimeter will be 0.5 meters. Done. This is clear. You just have to multiply with 10 raised to power minus 2 or divide by 100 for centimeter to converting into meters. Done. Okay. So this will be 1 divided by 0.5, right? That will be 10 by 5. That will be 2 diopters. So power is 2 diopters. Understood? Any doubt, let me know. I'll solve it. Any doubt if you have. Okay, moving on to next question. We have a student needs spectacle of power minus 0.5 diopter. As we read, we write. Why? Because we have to see the sign as well. 0.5 diopter. Be very careful. For the correction of his vision, name the defect of the vision the student is suffering from. Now how will we realize just from the power what defect student is suffering from, right? There is an order. So first we'll find out that the sign of power. The sign is what? Sign is negative, correct? If power has negative sign, so focal length will also have negative sign, correct? And we just studied which lens has negative focal length. Which lens? Convex or concave? Only convex lens, only concave lens. We know convex lens has positive, only concave lens has negative focal length. Concave lens has negative focal length. Now concave lens is used to correct which defect? Myopia or hypermetropia? Ma'am, myopia, hypermetropia, concave is for myopia, right? So concave is to correct myopia, and if we are using someone's vision to correct his or her vision, we are using concave lens. That means he has myopia. Done. Easy. This was easy. The way you saw how we reached till here. Okay. Power is a sign. The same sign will be of focal length. Now which lens has focal length as negative? That is concave lens. Which defect is corrected by concave lens? That is myopia. Done. First part is done. Okay, second, find the nature and focal length of the corrective lens. So nature we already told, that is concave lens. Now what is the focal length? Right, we have to find the focal length. So focal length is simply 1 by power. Power is minus 1 by 0.5, right? So focal length will be minus 2 meters. Focal length will be, okay, no, focal length will be not minus, yeah, this is, yes, correct, I did correct, I don't know, sorry about that. So focal length will be minus, see, this will be minus 10 by 5, 5 2s are 10, so this will be minus 2, but in meters. Done? Correct? Okay. Then we have list 2 causes of this defect. We have myopia. Okay, we have myopia. What are the causes of this defect? To write the causes, what happens in this defect? The image forms in front of the retina. The image forms in front of the retina. Right? Now, why image forms in front of the retina? What is the reason for that? So, reason is increased or decreased. Increase or decrease? It will be decreased focal length of our eye lens. F got vanished. ठीक है? Okay, decreased focal length of our eye lens. And second is what? Eyeball got bigger. Okay, bigger in size. Bigger in size. Done? Any doubt? The whole question is solved? Okay, very important. See, all the questions are of different kind, right? Okay, next let's read it carefully. A person wears a spectacle of power minus 2.5 diopter. Again, power is given as minus 2.5 diopter. Done. Name the defect of vision he is suffering from. So we have to find the defect of vision. Also look at how am I writing the question. I am writing what is given first, then I am writing what I have to find. Okay. What will be the focal length of the corrective lens? I also have to find the focal length of the corrective lens. Okay, everything is clear. Now again we go through that chronological order. What is that chronological order? Ma'am, first we see the sign of power. The sign is negative. The same sign will be of focal length. So focal length is also negative. Which lens has negative focal length? See how fast we are going. Which lens has negative focal length? Convex lens or concave lens? Let me know in the comment section if by now you remember it, your soul remembers it, that concave lens has negative focal length. So this is concave lens. Done. So concave lens has negative focal length. Then concave lens is used to correct which defect? Myopia or hypermetropia? Ma'am, it was myopia. So this person also has a defect, that is myopia. Done. We are done with the first part. Defect we found, right? We found that it is myopia. Done. Now we have to find the focal length. Focal length is simply the inverse of power. So this is 1 by P. That means this is 1 by 2.5. Okay. And this is minus 10 divided by 25. Correct. Now if you solve this, this will be 0.4. So this will be 0.4 but in meters. right? Can you solve this calculation? This is easy, right? 25, you just have to divide 10 by 25. It is easy, 0.0 and with 400 comes. Okay? Easy, very easy. Done? Okay, let's move on to the next question. We have the next question. A person can read the number plate of a distant bus clearly. Okay, but he finds difficulty in reading a book. He cannot read a book, but he can read a bus. Okay, what type of defect of vision he is suffering from? Let's just solve it till here. What is the defect that person is suffering from? If he can see far objects clearly, but nearby ones are blurry, right? So which defect is that, ma'am? This is simply, ma'am, this is very easy. This is hypermetropia. This is hypermetropia. Done? Easy. Name the type of lens he needs to correct this defect. Of course, to correct hypermetropia, we use concave or convex. Okay, this you have to tell me. Write down the answer of this question. The slide number is 12. So you can write 12 and which lens is used to correct that vision. Okay, name the type. Write the answers in the comment. Answers in comment. Which kind of lens is used to correct hypermetropia? Fill in the blanks. Convex or concave. Okay, write the causes of this defect as well. This then also you have to write, because I cannot answer half a question. Okay, so this I'm giving it to you. Done? 12th slide, you have to write 12 and answer in the comment. Okay, moving on, we have the near point of a person suffering from hypermetropia is 75. Now they have given us everything, but I told you, whenever near point is given, that near point will be our V. Okay, so now in this case V is minus 75 centimeter. Understood? Any doubt? Okay, calculate the focal length. I have to find the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeter. Now newspaper is my object, so U is what? It is 25 centimeter and U is always negative. We know that. We have to find focal length. Very easy, ma'am. We can directly use lens formula. Done? Okay, so lens formula is 1 by f equals to 1 by v minus 1 by u, right? We have to find focal length 1 by v. V is what? Minus 75. Do it very calmly and do it on a clean paper. Your handwriting should be clean, because if your handwriting is not clean and you write anything anywhere on the paper, you will get confused. Okay, so first I wrote given, and in the side I have written what I have to find, and here I am doing the solution. You also have to go through this particular thing, given to find, then the solution. Done? Now U is minus again 25. Done? Now 1 by f is simply minus 1 by 75 plus 1 by 25. Clear? If I get the LCM here, what will be the LCM? See, f equals to minus 1 by 75 plus 1 by 25. LCM will be simply 75. Okay, then this will be minus 1 plus 25 into 3 will be 75. Okay, so this will be plus 3, so that will be 2 by 75. F focal length, so focal length will be, oops, this was 1 by focal length, right? 1 by focal length. So focal length will be 75 divided by 2, that is 75 to 3 is 6, 15 is left, and that will be, wait, yes, that will be 714.5. So focal length is simply 37.5 centimeters. Any doubt, my friend? Any doubt? Okay? Okay. Now we also have to find the power, right? So power will be 1 by focal length. Simply power will be 1 by focal length, but focal length will be in meters, right? It is in meters. So power will be 1 divided by 37.5 into 10 raised to power minus 2, right? That is correct. And power will be 100 divided by 37.5, which you can write 1000 divided by 3075. Now that will be something around 2, right? Because if you do 3, that won't count. So 375 into 2 will be what? 0, 1, 14, 5, 1, 6, 7. So this will be 750. That will be 2 point. That will be, see, if you again use point, right, 250 will be left. So 250 by 2, 250 will be what? 250 divided by 375. We have to do 250 divided by 375. So again we'll add 1 point. That will give us 2500. Correct? That will give us 2500. Now again you have to see where 375 will be divided into. It will be, ma'am, we can do 7 because that is 21 into 3, right? So 7, let's say 7. So 7 5s are 35, 3, 49, 50, 51, 52, 5 above, but this is 21 and this becomes 2625, which is more than 2500. So that will be around 2.6. So you can leave the answer till here. So power will be 2.6 diopters, and you can write approx with this. Done. Easy. Even I told you how to do the calculations. Just do it a little bit fairly. Okay, just draw a line here in this part and do the calculation. Okay, moving on, we have near point of a far-sighted person. Near point of a far-sighted person is 40 centimeter. So again, whenever the near point is given, that is my V. Also minus, that is in negative. So V is minus 40 centimeter. He wishes to reduce it to 25 centimeter. Now that is my object, because देखो, if he wants to reduce it to 25 centimeter, that means he wants to place the object at 25 centimeter, right? So U will be 25 centimeter but in negative. Okay, by using spectacles, find the power and nature of the lens used by him. So again, ma'am, using lens formula, we can find the focal length, right? So 1 by focal length equals to 1 by V minus 1 by U. 1 by V, V is 40 centimeter, that is minus 40, and U is minus 1 by 25. Correct? This is correct. This is 1 by focal length. So what will be my LCM in this case? That will be around, we can take, let's just take 200, because we know 4 into 5 is 20 and 25 into 8 is 200 as well. So 200 is the safe bet. So let's just go with 200. Minus 40 into this will be minus 5, right? Plus this will be 8. So focal length will be 200 divided by, now 8 minus 5, that is 3, right? So focal length is simply 6.666, something like that. Yes, 6.67, but this is in what? This is in centimeters. Done. Everyone has any doubt? Okay, so U we have minus 25, V we have minus 40, F will be 6.657, 6.67. Hey, it will be not 6 point, right? It will be 66 point. Yeah. Okay. This will be 200. This is 200 divided by 3, not 20 by 3. Okay, 66.666. So you can write 66.67 centimeter. Done. Now we have to find the power as well. So power will be 1 by focal length, right? So 1 by focal length, can I simply write 3 by 200? 3 by 200, but it is also divided by 100 as well. See, what happens, this is in centimeters. So to convert it in meters, I have to do 200 by 3 divide by 100, right? Correct. So that will be 200 divided by 3 into 10 raised to power minus 2. Correct. So this will be, if I flip it, that will be 3 by 200 into 10 raised to power 2. So this will cancel out. This will be 3 by 2. That will be 1.5 diopter. Easy. Okay, I'll tell you again what I did. See, focal length was 200 divided by 3, but it is in centimeters. To convert it into meter, we multiply it by 10 raised to power minus 2. Correct? So this is 200 divided by 3 into 10 raised to power minus 2. Right? So that will be 200 into 3. Now this comes under, right? So this is 100. Okay, maybe I did wrong here, right? Now this 100 won't be here. This will be up. This will be in the denominator. This will be here, right? I'm telling you how. Just look at it. 200 by 3 is centimeter. We have to multiply it by 10 raised to power minus 2. Now if 10 raised to power minus 2 comes into denominator, that becomes 10 raised to power 2. So this 2 zeros and this cancels out. So focal length is 2 by 3 but meters, and for power we have 1 by f. So that will be now 3 by 2 meters, 3 by 2 diopters, right? So if you cut it, that will be 1.5. So power is simply 1.5 diopters. Good? Understood now? Okay. Next we have, a person wants to read a book placed at 20 centimeter. Now the book is placed at 20 centimeter. So book is my object. So object is u. U is always negative. So u is minus 20 centimeter. Done. Whereas near point of his eye is minus 30 or 30 centimeter. So what did I tell you? Whenever near point is given, that is my V. So V is minus 30 centimeter and it is always negative. Right? Calculate the power of the lens required. We just have to calculate the power of the lens. Again, we can find the focal length. How? Using the lens formula. Now, I am giving you this as homework because I have solved so many similar questions like that. You just have to put the values, find the focal length, right? Find the focal length, convert it into meters. Right? Then go find the power, which is 1 by focal length. Very easy. Let me know the answer. This is slide number 18. 18, answer in the comments. Okay? Answer in the comments. I'll check all your comments. So answer in the comments 18. Write down 18 and with that write down the answer. Okay? Okay. Next we have a far point of a short-sighted person. Now we were doing near point. Let's do a question of far point. Okay. Far point of a short-sighted person is 1.5 meter. So again, whenever the far point is given, that point will be my image distance V. That will be minus 1.5 meters. Done. Now this is in meters. Find the focal length. We have to find the focal length and power. Again, we have to find the power as well, and nature of the remedial lens. Nature of the remedial lens is also my corrective lens. Correct? Now be very careful. See, far point. What is the normal far point of a normal human being? That is infinity. Right? So that infinity is actually my object, because technically I want to see a very, very far away object, but my eyes allow only to see until 1.5 meters. So the actual object is at infinity, but my lens will make that infinite object's image first at 1.5 meter, then my eyes will be able to see that clearly. Right? So u will be infinity. Now this is minus or plus, it doesn't matter. Okay, so this will be 1 by focal length equals to 1 by V minus 1 by U, using lens formula again. Now 1 by focal length equals to 1 by V is minus 1 by 1.5, minus of this is infinity, so this term will become 0 because 1 by infinity is equal to 0. We know that, right? Now if 1 by infinity is 0, then this whole term cancels out, so focal length is simply minus 1.5 meters, right? Now let me tell you one more thing. If this is a short-sightedness, short-sightedness means it is myopia, it is short-sightedness, right? This is myopia. Now to correct myopia, which lens do we use? We use honestly, let me know in the section, comment section, 21 slide. We use concave lens, right? We use concave lens. Now focal length of concave lens is what? Is it negative or is it positive? Let me know in the section. Go into the comment section, write down, ma'am, it is positive or it is negative. I'll give you the answer in a second. Okay, written down honestly, be very honest. We are here, we don't cheat. This is our exam. So concave lens, focal length is always negative, right? Now look at the answer. Is it negative or not? It is negative. So that explains that my calculation is true. Okay, now focal length is negative. We found the focal length. First part is done. Power is just inverse of focal length, so power will be 1 by focal length. Now this is already in meters, so this will be minus 1.5, which will be 10 by 15, right? Now this will be what? Minus 2 by 3, right? And this will be 0.666, correct? So power will be minus 0.67 diopter. Any doubt? Done, right? 2 by 3, 3 will be 0.666666. That you can write 0.67. Okay, this done. Question is done. And nature we already found, that is concave lens. Why? Because focal length is negative. Done. Okay, we have one more question. Yes, a person having a myopic eye uses a concave lens. Everything is given of focal length 10 centimeter. Oh, this is a very decent question. Now, what is the main trick in this question? Why CBSE gave this question? Because you have to know the sign of concave lens, sign of focal length of concave lens. Is it positive? Is it negative? It is negative. Very good. So sign of focal length is negative. Now if focal length is negative, that is minus 10 centimeter. There can be 2-3 tricky questions, tricky things here. First is the sign, second is units. It is in centimeter. You have to convert it into meters. So focal length will be minus 10 centimeter divided by 100, which also means minus 10 centimeter into 10 raised to power minus 2. These two are the same things. We know that, right? Okay, so focal length is simply minus 10 divided by 100, which will be minus 0.1 meters. Okay, so focal length is minus 0.1 meter, and so power will be 1 by focal length. That will be 1 by minus 0.1. Sorry about that. So this will be minus 10 diopter. So power is minus 10 diopters. Done? Understood? We have done all kinds of questions. What were the questions? The near point was given, and then the far point was given. It was given that it is a myopic eye. Then it was given that the defect is hypermetropia or myopia. We had to find the corrective lenses. For myopia, we had to find the corrective lenses as well as the power. For far point, we needed to know what is V. For near point, we needed to know what is V. Anything left? We did all kinds of questions, all the important kinds of questions that can come into your exam. And I'm telling you, you can write it down. No other kind of question can come in your examination other than these. We will revise more kinds of questions in lives as well, do not worry about that, but these are normally the kind of questions that can come. Most of these are even most repeated PYQs. That's why I have got this as the most important questions for the chapter Human Eye. Okay, that is it for this video. Revise all the questions, be prepared for your examinations, stay healthy, drink a lot of water, move around, do not just sit at one place for 10 hours, 12 hours. You will get exhaustion very easily and that will impact your revision, your preparation. Okay, move around, get small breaks, it will be fine, and let me know in the comments how your preparation is going and what else you want from me. I'm standing here with you day in, day out, all night. You can contact me anytime. I'll be going lives as well. You can ask your doubts as well. Okay, till then, ta-da.